Using a 200 amp service with a 20 kilowatt furnace in a 2400 square foot home is generally considered adequate, but several factors are important to consider. Firstly, simultaneous usage is a key consideration. It's unlikely that all high wattage appliances will be operating at the same time. However, it's possible, especially during periods of high energy demand, such as cold winter days. Secondly, surge current is important. Electric motors, like those in furnaces, draw more current when starting up. This can temporarily exceed the rated amperage of the furnace. Thirdly, other electrical loads should be factored. In addition to the furnace, range, water heater, and dishwasher, other appliances and devices will also draw current. This includes lighting, electronics, heating, ventilation, and air conditioning systems, and anything plugged into outlets. To estimate the basic load for everyday usage, consider the following. Firstly, lighting needs to be estimated. Assume 100 watts of incandescent lighting per average sized room, around 4 by 4 meters. With 10 rooms, this would be 1 kilowatt. Secondly, non-appliance plug circuits need to be estimated. Estimate 300 watts of plugged-in devices per room, such as computers and fans. Again, with 10 rooms, this would be 3 kilowatts. Thirdly, other intermittent loads are considered. Consider 1 kilowatt for miscellaneous intermittent loads, such as hair dryers and toasters. The total basic load is calculated as follows. Lighting is 1 kilowatt. Non-appliance plug circuits are 3 kilowatts. Intermittent loads are 1 kilowatt. The total is 5 kilowatts. With a 20 kilowatt furnace, a 200 amp service provides approximately 42 amps of headroom. This is calculated as 200 amps minus 158 amps. This headroom should be sufficient for most normal home electrical needs, including lighting, non-appliance plug circuits, and other intermittent loads. However, if there are plans for future upgrades or expansions that could significantly increase electrical demand, a 300 amp service may be more appropriate. To elaborate further, let's break down how to perform a more detailed load calculation to determine if a 200 amp service is sufficient. The first step is to determine the general lighting load. For dwelling units, the NEC, National Electrical Code, specifies a general lighting load based on the square footage of the dwelling. According to NEC Table 220.12, the unit load for dwelling units is 3 volt amps per square foot. For a 2400 square foot home, the general lighting load is 2400 square feet times 3 volt amps per square foot, which equals 7200 volt amps. The second step involves small appliance branch circuits. NEC Section 220.11 requires a minimum of 220 amp small appliance branch circuits for the kitchen and dining area. These circuits are rated at 1500 volt amps each. Therefore, the total load for small appliance branch circuits is 2 times 1500 volt amps, which equals 3000 volt amps. The third step involves laundry branch circuits. NEC Section 220.11 also requires at least one 20 amp laundry branch circuit, rated at 1500 volt amps. The fourth step involves applying demand factors. A demand factor is a multiplier used to reduce the calculated load, recognizing that not all loads will be in use simultaneously. For the general lighting, small appliance, and laundry loads, NEC Section 220.42 allows a demand factor of 100% for the first 3000 volt amps and 35% for the remainder. In this case, the first 3000 volt amps are taken at 100%, which equals 3000 volt amps. The remainder is 7200 volt amps plus 3000 volt amps plus 1500 volt amps minus 3000 volt amps, which equals 8700 volt amps. This is taken at 35%, which equals 3045 volt amps. The total load after applying the demand factor is 3000 volt amps plus 3045 volt amps, which equals 6045 volt amps. The fifth step involves the range calculation. For an electric range, NEC Table 220.55 provides demand factors based on the number of ranges. For a single range rated not over 12 kilowatts, a demand factor of 8 kilowatts or 8,000 volt amps is typically used. The sixth step involves the furnace calculation. The furnace is rated at 20 kilowatts or 20,000 volt amps. Since it's a fixed appliance, it's calculated at 100%. The seventh step involves the water heater calculation. Assume a typical electric water heater rated at 4.5 kilowatts or 4,500 volt amps. This is also a fixed appliance and is calculated at 100%. The eighth step involves the dishwasher calculation. Assume a typical dishwasher rated at 1.5 kilowatts or 1,500 volt amps. This is also a fixed appliance and is calculated at 100%. The ninth step involves motor loads. If there are any other significant motor loads, such as a well pump or central air conditioner, these should be included at 125% of their full load amps FLA rating, as per NEC section 430.24. Let's assume there is a central air conditioner with a full load amps rating of 20 amps at 240 volts. The load is calculated as 240 volts times 20 amps times 1.25, which equals 6,000 volt amps. The 10th step involves other loads. Include any other significant loads such as electric dryers, hot tubs, or other large appliances at 100%. Let's assume there is an electric dryer rated at 5 kilowatts or 5,000 volt amps. The 11th step involves calculating the total connected load. Add up all the loads calculated in the previous steps. The total connected load is 6,045 volt amps, lighting and small appliances, plus 8,000 volt amps, range, plus 20,000 volt amps, furnace, plus 4,500 volt amps, water heater, plus 1,500 volt amps, dishwasher, plus 6,000 volt amps, air conditioner, plus 5,000 volt amps, dryer, which equals 51,045 volt amps. The 12th step involves calculating the total amperage. Divide the total connected load in volt amps by the voltage of the service, which is typically 240 volts for a residential service. The total amperage is 51,045 volt amps divided by 240 volts, which equals approximately 212.69 amps. Based on this detailed load calculation, the total calculated amperage is approximately 212.69 amps. This exceeds the 200 amp service rating. However, it's important to note that this calculation includes all loads at their maximum demand, which is unlikely to occur simultaneously. The NEC allows for demand factors to be applied to certain loads, such as the range, to account for this. Applying demand factors can reduce the calculated load to a value closer to the actual expected load. Even with demand factors, the calculated load may still be close to the 200 amp service rating. In this case, it would be prudent to consider upgrading to a 300 amp service to provide additional capacity for future needs and to avoid overloading the electrical system. Additionally, consider the following points. Firstly, future expansion. If there are plans to add any significant electrical loads in the future, such as a swimming pool, hot tub, or electric vehicle charging station, a 300 amp service would be highly recommended. Secondly, safety margin. It's always a good idea to have a safety margin in the electrical system to avoid nuisance tripping of circuit breakers and to ensure reliable operation of all appliances and devices. A 300 amp service provides a larger safety margin than a 200 amp service. Thirdly, local codes and regulations. Check with the local building department to determine if there are any specific requirements for the size of the electrical service for a home with a 20 kilowatt furnace. Some jurisdictions may require a 300 amp service in this situation. Fourthly, professional consultation. It's always a good idea to consult with a qualified electrician to perform a load calculation and to determine the appropriate size of the electrical service for a particular home. An electrician can take into account all the relevant factors and provide a recommendation based on the specific needs of the homeowner. In summary, while a 200 amp service may be technically adequate for a 20 kilowatt furnace in a 2,400 square foot home, it's important to consider all the factors discussed above, including simultaneous usage, surge current, other electrical loads, and future expansion plans. In many cases, a 300 amp service would be a more prudent choice to provide additional capacity, a larger safety margin, and to avoid overloading the electrical system. Remember to always consult with a qualified electrician to perform a load calculation and to determine the appropriate size of the electrical service for a particular home. A few more points should be added to the discussion. Firstly, energy efficiency. Consider upgrading to more energy-efficient appliances and lighting to reduce the overall electrical load. For example, LED lighting uses significantly less energy than incandescent lighting. Energy Star-rated appliances also use less energy than standard appliances. Secondly, load management. Implement load management strategies to reduce the peak demand on the electrical system. For example, avoid using multiple high-wattage appliances at the same time. Schedule laundry and dishwashing for off-peak hours. Thirdly, surge protection. Install surge protection devices at the service panel and at individual outlets to protect against voltage surges which can damage electronic equipment. Fourthly, regular maintenance. Have the electrical system inspected regularly by a qualified electrician to identify and correct any potential problems. This can help to prevent overloading and other electrical hazards. Fifthly, understanding demand factors. Demand factors are crucial in accurately assessing the load requirements. The NEC provides tables and guidelines for applying demand factors to various types of loads. For example, the demand factor for a range is significantly lower than 100% because it's unlikely that all heating elements will be in use simultaneously. Similarly, the demand factor for multiple appliances is lower than 100% because they are unlikely to be used at the same time. Accurately applying demand factors can result in a more realistic assessment of the load requirements and can potentially avoid the need to upgrade to a larger service. Sixthly, consider the impact of electric vehicle charging. If there is a plan to purchase an electric vehicle in the future, consider the impact of electric vehicle charging on the electrical load. Electric vehicle chargers can draw a significant amount of current, especially level 2 chargers, which can draw up to 40 amps or more. This can significantly increase the peak demand in the electrical system and may necessitate upgrading to a larger service. Seventhly, smart home technology. Consider incorporating smart home technology to monitor and manage energy consumption. Smart thermostats, smart lighting, and smart appliances can help to reduce energy waste and optimize energy usage. Smart energy monitors can also provide real-time data on energy consumption, allowing homeowners to identify areas where they can save energy. Eighthly, renewable energy sources. Consider installing renewable energy sources, such as solar panels, to reduce the reliance on the grid and to offset some of the electrical load. Solar panels can generate electricity during the day, reducing the amount of electricity that needs to be purchased from the utility company. This can help to lower energy bills and reduce the overall demand on the electrical system. Ninthly, understanding the service entrance. The service entrance is the point where the electrical service enters the building. It typically consists of a service panel, a meter, and a disconnect switch. The service panel is the main distribution point for electricity in the building. It contains circuit breakers that protect the individual circuits from overloads. The meter measures the amount of electricity that is consumed. The disconnect switch allows the power to be disconnected from the building in case of an emergency. Tenthly, understanding circuit breakers. Circuit breakers are safety devices that protect electrical circuits from overloads. When a circuit is overloaded, the circuit breaker trips, interrupting the flow of electricity. This prevents the wires from overheating and potentially causing a fire. Circuit breakers are rated in amps, which indicates the amount of current they can carry before tripping. It's important to use the correct size circuit breaker for each circuit to ensure proper protection. 11thly, understanding wire gauge. Wire gauge refers to the thickness of the wires used in an electrical circuits. The appropriate wire gauge depends on the amount of current the circuit will carry. The NEC provides tables that specify the appropriate wire gauge for different ampacities. Using the correct wire gauge is essential to prevent overheating and potential fire hazards. 12thly, understanding voltage drop. Voltage drop is the decrease in voltage that occurs along a wire due to the resistance of the wire. Excessive voltage drop can cause appliances to operate inefficiently and can even damage them. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. 13thly, grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and energize the circuit. Bonding connects all metal parts of the electrical system together to ensure that they are at the same potential. This prevents voltage differences that could cause electric shock. 14thly, arc fault circuit interrupters, or SIs. SIs are circuit breakers that are designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. SIs detect arc faults and trip the circuit breaker, interrupting the flow of electricity and preventing a fire. The NEC requires of SIs in many areas of the home, including bedrooms, living rooms, and dining rooms. 15thly, ground fault circuit interrupters, or GFCIs. GFCIs are circuit breakers that are designed to protect against ground faults. Ground faults occur when electricity flows through an unintended path to ground, such as through a person's body. GFCIs detect ground faults and trip the circuit breaker, interrupting the flow of electricity and preventing an electric shock. The NEC requires GFCIs in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor areas. 16thly, electrical permits. Electrical work typically requires a permit from the local building department. The permit ensures that the work is done in accordance with the NEC and local codes. It also provides for inspection of the work to ensure that it is safe and compliant. 17thly, hiring a qualified electrician. Electrical work can be dangerous and should only be performed by a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also ensure that the work is done in accordance with the NEC and local codes. 18thly, electrical safety tips. Always turn off the power before working on any electrical circuit. Use insulated tools. Never work on electrical circuits while standing in water. Keep electrical cords and appliances away from water. Never overload electrical outlets or circuits. Have the electrical system inspected regularly by a qualified electrician. Finally, remember to always prioritize safety when working with electricity. Electricity can be dangerous, and it's important to take precautions to avoid electric shock and fire hazard. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you.